Good night, professor and classmates. My teammates Viviana Araya, Edwin Granados, Gloriana Hernandez, and myself, Victor Mena, are going to talk about the different technologies Tdma, Cmda, UMTS, LTE, and 5G. For this exposition, we have the following agenda. First, we'll have the introduction. Secondly, the multiple access techniques. Third, the time division multiple access and the code division multiple access. Fourth, the universal mobile telecommunication system, the LTE, 5G, and finally the conclusion. This investigation we made had the purpose to provide information on different technologies used by mobile devices. The different technologies studied are the multiple access techniques, the universal mobile telecommunications, that's UMTS, the 4G and 5G. In addition, we're going to explain its operation and its main characteristics. Also, some applications that have been made on this type of technology will be provided, and the evolution of this has been improving for proper operation over the years.
What are multiple access techniques? Multiple access or techniques allow a certain numbers for users simultaneously connected to the same medium to transmit and receive information by sharing their capacity. Shared media can be, for example, ring networks, bus networks, or wireless networks. Given the problems that arise when accessing a communication channel simultaneously and with limited resources, multiple access techniques are responsible for ensuring its users that the access will be optimal. Multiple access is given through the multiplexing for uses and is carried out in the physical layer of the communication systems through the multiple access protocol and a control mechanism called medium access control, located in the layer 2 of the OSI data in the layer model. The multiple access protocol is responsible for performing tasks such as preventing collisions between users and distributing resources among them. There are different methods of multiple access depending on the way to devise the resource. However, the four main methods are multiple access by frequency division, space division multiple access, time divisions multiple access, and multiple access by code divisions. In this presentation, we will only take a closer look at the last two. Frequency division multiple access. It divides the same frequency band into the small frequency channels that its transmitter and receiver uses a separate frequency. The first generation, which emerged between in the 1970s and 1980s, was based on FDMA. Space divisions multiple access. It reused the same carrier frequency by users separate at such a distance that they cannot interfere with each other. Time divisions multiple access. This technique consists of making the full bandwidth available to all signals in a time-sharing regime. Communication is carried out through a storage and forwarding scheme. In this way, the information is first stored and then transmitted. Before the information is transmitted, it remains stored for a range of time known as a frame. The transmission runs within a time slot. Each channel is a time slot on a specific frequency. This technique, along with CDMA, are the most widely implemented multi-access techniques. Among the implementations that have been given to this technique, second-generation digital system consists, since each channel is divided into 8 time slots, which together make up the TDMA frame. Foregoing allows simultaneously transmissions, but discontinuous, but on the same carrier frequency of information packets. Its call in a cell implements a time slot with a frequency band to transmit and another frequency band to receive, generating a bidirectional connection. Its receiver has the possibility of selecting the burst with its number. In this way, the traffic capacity is increased, this being an advantage of using digital transmissions. Another use of the technique is made by the Global System for Mobile Phone Communications, since they use Tdma on a FDMA basis. In place the use of digital techniques for voice compress, it eliminates the redundancy and the period of silence in the audio. As the last example of the use Tdma, it is the one used in Europe through the Tdma system. This system has frequency in the specific bands for emergency system and for the inhabitants. Tdma has developed from 1990 by the European Telecommunications Standard Institute and uses Tdma access technique, allowing group calls as open channel. In addition, it supports circuit switch, voice service, packet data services.
Now I am going to explain the code division multiple access CDMA. The technology that comes from wireless communication is going to implement CDMA because it is a new concept of cellular network. This technique takes a different approach from that of TDMA and GSM. It is the most modern digital wireless technology that paved the way for a new generation of wireless communication products and services. It consists of spreading the data through the channel after the channel is digitized. There can be multiple calls on top of the other in the entire channel. However, each one has a sequence code which allows a different signal to be maintained for each call. It transmits throughout the available frequency range. It does not assign a specific frequency to each user in the communication network. The method it uses is multiplexing, which makes transmissions difficult to be blocked. It is used by 2G and 3G wireless communication, generally operating in the frequency range of 800 MHz to 1 GHz. So now that CDMA works by applying analog to digital conversion. This in conjunction with a spread spectrum technology. The audio input is digitized into binary elements. Then the frequency of the transmitted system broadcast signal varies according to the defined pattern, which allows it to only be intercepted by a single receiver whose frequency response is programmed with the same code. One characteristic of cell phones with CDMA network is that they do not use a SIM card, thanks to the fact that each device is using the service as a specific network provider. Although the application of CDMA in telephony is relatively new, the technology is not, because CDMA was used in many military applications, such as an anti-blocking, which was difficult to block or jam the frequency. The CDMA standard for cell phones is the IS-95, defined by the Telecommunication Industry Association. Some of the benefits of this technology are among them the voice and call quality stand out as it filters out the background noise and interference so that you can enjoy better quality calls. Another advantage is that they are built with an standard IP packet data protocols and a greater security and privacy is one of the strengths for this technology because it eliminates cloning and other types of fraud.
The Universal Mobile Telecommunication System is a third-generation mobile radio access technology, successor to GSM because GSM technology could not follow an evolutionary path to provide services considered third generation. With the offer of multimedia services, the demand of their speeds increased to achieve a better quality of service. UMTS has been designed for the global movement. It has ability to work with the internet protocols. As a result of the higher bandwidth, a large number of applications are available for clients and companies. Initially intended for use in mobile phones, but the UMTS network can be used by other devices. Three great characteristics of UMTS are the multimedia possibilities and high internet access speed, which also allows you to transmission audio and video in the real time, and a voice transmission with the quality comparable to that of fixed network. Its transmission speed added to the inherent support of the Internet Protocol (AP) combine powerfully to provide interactive multimedia services and new broadband applications. The advanced functions of UMTS have helped to improve tools that were started to be implemented with GSM. These include greater data security by being able to better authenticate authorized reception stations. It has also been decisive for the development of next-generation networks such as LTE. The 3GPP protocol is actually the basis of which the well-known 4G was created, so that it can be said that UMTS is the previous step of the global communication system that turned analog telephony into digital. To the world of mobile internet, objects connect to the IoT, and even the future 5G, which will soon be in operation. With the UMTS system, the concept of mobile phone has radically changed, going from being a simple communication instrument to becoming a multimedia terminal with multiple capabilities for communication and leisure, thanks to the large number of services offered that grow day by day.
4G LTE. To understand the concept of LTE, the fourth generation, or also known as 4G network, must be previously defined. Due to its high download speed, this network stands out for providing an ideal speed level for services such as video calls, live broadcast, among other services. The International Telecommunication Union is the regulatory entity of these networks. It specified that when the 4G network was created, it was not at maximum speed capacity. However, with the requirements introduced, it could not continue to be called 3G either. A clear example of this requirement is that 4G networks were initially supposed to have a speed level of up to 1 GB per second, but most networks supported 70 or 100 megabytes. To understand the difference between 4G and LTE, we are going to use a very simple example. Imagine that you want to download a video game or a movie that has a size of 4 gigabytes. Also, imagine that you are going to transport the downloading cards and each one will take 1 gigabyte. In the case of 4G, it will have a single path, which slows the arrivals of the files. On the other hand, with 4G LTE, more paths will be enabled, so that the arrival of the files is faster. Observe how the vehicles arrive at the same time. With the above, it can be said that 4G networks have evolved in their speed capacity growth. It is at this point when the issue of long-term evolution, or LTE, as it is commonly now enters. This is a technology that refers to wireless broadband that serves to transmit data in order to give internet access to mobile device. LTE can be seen as the standard for uploading and downloading data from the network at high speed. In summary, it can be said that 4G is a classification, while LTE is a technology used for data transmission. However, as mentioned, 4G networks were created in order to have a capacity of up to 1 gigabyte. It is at this point when the union of 4G LTE advanced appears, which basically allows capacity up of 10 times higher than those of normal LTE, reaching in some networks to reach up to 950 megabytes, which is close to the proposed goal. 5G. To understand the importance of 5G, it's necessary to make a prior analysis of the current situation in the internet consumption. In Europe, each user consumes 4 gigabytes on average per month, but it is estimated that by 2024 each user consumes an average of 40 gigabytes in the same amount of time. Now multiply the same amount by the number of active users worldwide. It is logical to think that the network has to evolve to 5G. This is precisely what 5G means, the fifth generation of the evolution of mobile communications. With the previous analysis, two great needs are identified. The first is the number of users that currently exist together with the demand for the internet that they generate, and the second is the number of devices that are created and increasingly use the internet for their functions. To meet this demand, the network is needed that has the necessary capacity to meet the needs and that has the lowest possible latency. It can be said that currently with 4G it's what like having a good race and in good condition, but that is it has few lines and every there is more and more traffic, and that for this reason it can no longer cope, while 5G will have wider roads that provide space for more users. It can be said that 5G has improvements in three main aspects: speed, decreased latency, and higher density, because it allows a greater number of connected devices. Among the improvements in speed, it can be said that the 5G network presents characteristics such as a speed capacity of the 20 gigabytes per second, 20 times more than in 4G. In terms of latency, 5G presents 1 millisecond in its ultra-reliable low latency mode, while in 4G LTE it was 20 milliseconds. And finally, in terms of density, the 5G network will allow up to 1 million connected devices per square kilometer, while 4G allows 3,000 220 connected devices per square kilometer.
And finally, to conclude, the UMTS has an advantage over the second generation mobile 2G and its ability to support high data rates. Also, the 5G has improvements in three main aspects such as speed, lower latency, and higher density. Also, after the implementation of the UMTS system, the concept of mobile phone has radically changed, going from being a simple communication instrument to becoming a multimedia terminal with multiple communication and entertainment capabilities. And finally, the Tdma together with the Cdma are the most widely implemented multiple access technique.